Cruising near the edge of space at twice the speed of sound, the Concorde is a needle-nosed Mach 2 airliner defined by its drooping nose and ogival delta wing. From a technical standpoint, the design was a triumph. The engineering teams mastered the unique gauntlet of supersonic flight, solving complex problems in aerodynamics, propulsion, and the intense thermal heat generated at Mach 2. Yet this engineering masterpiece resulted in a commercial catastrophe. Of the initial rush of options from 16 different airlines, almost every order was eventually canceled, leaving just 14 jets to ever enter service. Because the hardware functioned exactly as intended, the cause of the project's failure lies elsewhere, in constraints that clever engineering simply couldn't solve. Breaking the sound barrier doesn't produce a single crack. A supersonic plane drags a continuous shockwave along the ground. A 1964 test deliberately boomed Oklahoma City daily, resulting in shattered windows, damage claims, and a public at its limit. The political reaction was immediate. In 1973, the United States enacted an outright ban on civil overland supersonic flight. This single regulation killed the plane's most profitable potential route, Los Angeles to New York, in 2 hours. The Concorde was legally confined to oceanic crossings, where its shockwave wouldn't hit land. The aircraft reached its technical goals, but hit a regulatory wall that erased its most important addressable market. Beyond the noise, the aircraft faced a punishing economic reality. To maintain Mach 2, the engines consumed fuel at a rate that defied the standard logic of airline profitability. This massive fuel consumption had to be offset by a tiny payload of only 100 passengers. To even approach a profit, airlines had to price a seat at roughly 30 times the cost of a standard economy fare. Even with those extreme ticket prices, the plane had to fly half full just to break even. It was a fragile business model that could not survive the 2000 crash and the travel slump that followed 9/11. Ultimately, the product failed because the market willing to pay that specific premium for speed never existed at the necessary scale. Modern successors have internalized these failures. Boom Supersonic's Overture, for instance, is being designed with a very different set of constraints in mind. They are targeting a slightly slower Mach 1.7 speed and explicitly planning for the 600 over water routes where the overland regulatory ban never applies. Meanwhile, NASA's X-59 is built for one purpose: to reshape the shockwave into a soft thump. It is an attempt to dissolve the regulatory constraint at its physical root. 50 years on, the industry has redefined the challenge. The central goal has shifted from the physics of speed to the politics of public and regulatory permission. The team that built the Concorde successfully answered every constraint they were experts in. They mastered the aerodynamics, the heat, and the propulsion. But a design defined only by technical constraints risks becoming a perfect answer to a question the wider world refuses to ask. The concept phase is the only window available to map the entire constraint landscape, including the unglamorous economic and regulatory hurdles that don't yield to engineering cleverness. The most dangerous constraints are those outside your expertise, precisely because they are the easiest to wave away as someone else's problem. At Depix, we keep the Concorde story as a cautionary twin to every wouldn't it be incredible if concept. Design decisions are cheap as a sketch, brutal once tooled. See every angle before you build.